Hi there and welcome to this class. Let's solve this particular problem in the study of physics. Let's look at a problem under resistor. So last class we dealt with a sample problem under resistor. This is the part 2 to the example. So let's look at how we can possibly evaluate this particular problem using the knowledge of resistor. If you are not familiar with resistor, if this is your first time, I'll drop the link to introduction to resistor in the description below in the video description, right? So go there and check the link there to take you directly to our previous classes where we dealt with resistor introduction, right? Let's look at how this is possible. It says, considering the following circuits, complete the table. All right, I have this circuit here. So in this circuit here, I have three resistors, R1, R2, R3, where the R1 is 120 ohms, R2 is 180 ohms, and R3 is 270 ohms. That's case 1. Case 2 is that this circuit have a voltage of 15 voltage. Alright, I have this place. It says I'm has to complete this table. It means I need to find, this is voltage column, voltage row, let's say, current row, and resistor row, as you can see. And I have the power row. So I'm looking for voltage, current, and power for each resistor. So it means I need to find V1, V2, and V3. I need to find I1, I2, and I3, perhaps R total and I total. I'm asked to find the power at section 1, power at 2, power at 3, and total power. What do you do in this case? Yes, I did. First things first, my first task is obviously to find my total resistor, right? Total resistor. And observe that this circuit here, it's simply a circuit with a resistor. And for a circuit with a resistor there, we expect two things, either in series or parallel. In this case here, this resistor R1, R2, R3, if you check this very well, and if you're familiar with our previous classes, this simply R1, R3, sorry, R1, R2, R3 obviously are arranged in parallel. If you are in our previous classes, you should know why this one is in parallel. So I'm saying this, please. Solution. So we said that both R1, R2, and R3 are in parallel. All right, so we know that R1, R2, R3 are in parallel arrangement. Like that is a side-by-side arrangement of resistor. This one is true, so it means that I'm going. So here's the idea. The equivalent, because my total equivalent, here's the idea. If I pick up R1, R2, R3, aside R1, R2, R3, there is no other resistor in this circuit. So automatically, because what my R total that I'm looking for. So R total, perhaps for resistor arranged in parallel, the formula I express in fractional form. So it means that in this case here, I'll be having 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. All right, so this is for parallel arrangement. If this one is true, put in values. Let's get R total. 1 over R total is equal to 1 over, what's R1? R1 is 120, so I have 120 plus 1 over, what's R2? R is 180, so 180 plus 1 over, what's R3? Of course, 270. I have 270. All right. Work this out. This gives you 1 over R total is equal to, now to solve this LCM, it might be broad or too stressful. What do you do? In case of big numbers like this, just divide them. So just punch 1 over 120 plus 1 over 180, punch the calculator, get the values, and let's see what we get, please. All right, in this case here, I have 1 divided by 120. This gives you about 0.0083 plus 1 over 180. So 1 divided by 180, this man gives me 0.0055. All right. Plus, let's see, 1 divided by 270, this man gives me 0.003737. All right. At this point here, I have 1 over R total is equal to, add them up, what do you have there? This man gives you 0.0083 plus 0.0055 plus 0.0037. This man gives me 0.0175. Of course, I can attach an invisible one here over 1. You say, okay, still the same thing, right? The same thing. From here, I have perhaps if I want to, I will invert the two of them, right? Inverse them. So inverse the two of them. So take this R total. So I have R total over 1. Observe, inverse them is equal to this one. Come up first. 1 over what? 0.0175. I have inverse them. So take it, switch it up. This one comes down. R total here comes up. I inverse them, each of them. From here, 1 over R total gives you R total is equal to 1 divided by this value. So 1 divided by 0.0175. This man gives you 57.114, perhaps 14 ohms. So my R total is equal in value to 37.14 ohms. So I can come here. My R total gives me about 57 point, perhaps 14, let's say 3.1. All right. My R total is equal in value to 57.1. Let's get voltage in the circuit, please. Let's get voltage in the circuit, please. All right. Let's work on the voltage calculation, please. All right. Calculating for voltage. Let's look at voltage calculator in bracket V. Let's look at voltage calculation. Now listen please, here's the idea and the concept. For voltage calculation there, here is the idea please. In my circuit here, I have 15 volts here in my circuit. So here's the idea please. I'm asked to find voltage. Now note this very important please. Note this please. Note this very important. Note please. When resistors are arranged in parallel, please note please. When resistors are arranged in parallel, as in this case, the same potential difference flow through them. The same potential difference flow through them, or the same voltage flow through them. When resistors are arranged in parallel, the same voltage flow through them. All right. When resistors are arranged in parallel, we said the same voltage, or if you want to, the same potential difference PD flow through them. All right. Now here's the idea. These resistors are all arranged in parallel. It means that this R1, R2, R3, they share the same voltage, right? So I'm saying that V, what's V? In the question, V is what? 5 volts. That's V, 15 volts per second, 15 volts. But R1, R2, R3 are arranged in parallel. And we said when resistors are arranged in parallel there, they have the same voltage. It means that for my V1, this part here, we're saying that V is equal to V1 equal to V2 equal to V3 equal to 15 volts. So V is 15 volts, V1 15 volts, V2 15 volts, and V3 15 volts. Why? Because we said One resistor are in parallel, they have the same voltage. So from here, V1 is 15. I have 15 here. I have 15 here. I have 15 here. So I've gotten my voltage across this resistor. Now, after that, let's do current calculation. Let's look at current calculation, please. Let's do current calculation. Let's do current um, calculation, or perhaps you can say calculate for the current. So in bracket I is current. So let's do current calculation. Now here's the idea. To get my current, I'll simply apply the idea of Ohm's law. Right? To get current there, I'll simply apply the idea of Ohm's law. In this case here, I've gotten V. I can easily get current. First is first. Let's get current. All right, look at this. What do we know from Ohm's law? From Ohm's law, we said that current, perhaps we said that V is equal to IR. I want to get current in this case. Make I subject. In this case, I will be equal to V over R. In this case here, express this in terms of total. I have that current total will be equal to voltage total all over R total. R total. What's my voltage total? Total voltage here is 15 because R total, this is a total voltage, right? That's 15 all over. What's my resistor total? R total, my R total resistor total is 57.1. That's 57.1. It means that my I total will be equal in value to, if I point this out, 15 divided by 57.1, this man gives me 0.26 ohms ampere. 0.26 ampere. So the value for I total here, that is my total here for I current I total is of course 0.26. With this technique here, I'll get for I1, I2, I3. Let's get for I1, I2, I3 using the same formula pattern, right? So I'll take this off. Let's get I1, I2, and then I3. In this case here, observe that I use this format that says I equal to VR, express them in terms of 1, 2, and 3. So it means from here, I'm having for I1, so I1 will be equal to V1 over R1. To get I1, what's V1? Say for V1, so at 1, this V1, 15 all over. What's R1? R1 is 120, so 120. This man gives me 15 divided by 120. This man gives me 0.125. Sorry. This one gives me 125 ampere. That's the value for I1. So I1 here is simply 0.125. All right. Let's get I2. From here, I2 is equal to V2 over R2. This man gives you V2 is of course 15 because they have the same voltage all throughout. So 15 over R2 is 180. So 180. This man gives you 15 divided by 180. I have 0.08 0.08 per se 0.083 ampere. So this one gives you 0.083 ampere. That's my I3. I2. Let's get I3 please. For I3 is equal to V3 over R3. This is equal to what's V3? V3 is 15 because they share the same voltage all over. What's R3? That's 270. So 270. This one gives you 15 divided by 270, this gives you 0.055 ampere. So coming here, I have 0.055 ampere. So this is how you look for, okay, how does I find the current in this circuit. One last thing, let's do power calculation. Now listen, I'll do power calculation for just number one. I'll look for this part here. You will look for this and part for me. So I'll look for P1. You will look for P2, P3, and P total for me. How good? That's what we do here in this case, right? So let's do power calculation. Let's do power calculation. Let's do power calculation. All right. Let's work on power calculation. So let's do power calculation. Calculating for power in the circuit. Right, let's do power calculation for power in brackets P. Of course, your power is measured in watts, right? So for power, when it comes to voltage, resistor, capacitor, etc, like when it comes to that concept, power in this case, P is equal to IV, right? So P is equal to IV in this case. First, I can, okay, here's the idea. If I wish now, I can say, what do we know? We know that V is equal to IR. This man from Ohm's law. So I can say that this power P can still be expressed as I have I. V, what's V? You said V is what? IR. I have in brackets IR. Multiply this I times I gives you I squared into R. I can use this formula for power. Either this or this. You should have the same answer or approximately the same answer. So let me go with this, because if I want to go with this, current have different value, but voltage have the same value all through. So I don't want to use same value all through. So let me just try to use I square, that is, I'm using current and what? Resistor, because we have different resistor values. So let's go with this, please. Let's go work with this. It's like that. I can start, okay, here's attacks. I'll look for P1. So for P1 will be equal to I1 squared. That's I1 squared into R becomes your R1. I have this place. So you look for RP2, P3, and R2 and P total for me, right? Leave your answer in the comment section, right? So P1 here gives you I1. What's I1? This value 0.125 all squared into what's R1? That's 120. So I have 120. P1 will be equal to 0.125 square gives you 0.125 times 0.125. 125. This one gives you about 0.0156, right, times 120. P1 will be equal to the power given out at section 1 will be equal to 120. That's 1.9 watts. So P1 gives you 1.9 watts. Please help me get P2. Help me get P2, P3, and P total. Please, to get your P total, what do? It's easy as P total is equal to I square total dot R total. That's all. What's your R total? Is 15. Sorry, is 57.1. What's your I total? I total is 26.6. Right? And get P total for me. That's all. So get P2, P3, and P total for me. So get P2. So get P2. Find me P2. Find me P3 and P total. See you guys in the next class. So the idea is that I'm giving a task to do. The task is easy as get me P2 and P3 and also P total. Leave your answer in the comment section. I'll reply you if you are wrong or correct. If you found this class helpful or interesting, do well to like this video, share to your friends and classmates, and also do well to subscribe to this channel. If you are new to this channel, I will appreciate you to subscribe to this channel. Very, very important. Also, if you are interested in learning more or if you're interested in videos like this, you can do well to join my channel membership. So in the channel membership, you have exclusive content there that can help you navigate your STEAM courses or STEAM courses or tutorials. Yeah, see your STEAM courses there. So you can go to there and get my courses on the membership. So you have exclusive content to watch. Aside that, you can also visit my website to get courses there. I have books that I can buy. I also have courses that I can get. So do to get my website at www.dynamically.com. So in my website there, you have access to different courses and also books. If you found this class helpful, once again, leave a comment. The comment you are leaving is simply for you to find P2, P3, and P total for me. All right, see you guys in our next class, and welcome to Excellent Link Academy.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen,